Let's switch to transformations now. Now, the transformations you have, excuse me, we had already done some looking at the transformations. Now, we talked in class about a couple of ways to do this. You can do it visually if you know what each piece of it means, know what goes on inside the parentheses and outside the function. So you can do it thinking of it that way. So you can think about taking every point on your graph, and this tells you you're going to add 1 to the x value. Then the y value, you're going to take its opposite, that's the vertical flip, and then add 1 to it. Okay, that's the same thing as saying if you want to do it, and then you would just apply that to every point on the graph and then connect your dots. Or you can do it by taking the point and going directly to the graph, where you take each point, you move it to the right one, reflect it across the x-axis, which is a vertical flip, and then you shift it up 1. And you should end up in the same place. So let's start here. If I take this point and move it to the right one, and then reflect it across the x-axis and move it up 1, I end up right here. Well, that is the point -2, 2. If I take this point, move it to the right one, reflect it across the x-axis, and then shift it up 1, that's right here, the point 0, 0. I always do this in pencil because I'm bad about making mistakes. Okay, if I take this point, move it to the right one, reflect it across the y-axis, which means the -3 becomes +3, and then move it up 1, it moves to the point 5, 4. If I take this point, move it to the right one, reflect it across the x-axis, and then move it up 1, it takes me to right there, which is the point 7, -2. So either way you do it, it's the exact same thing. And I've lost my ruler, and now I just connect my dots. So I go from here to here, and then up here, and then down to here. So whichever way makes sense to you. And again, you may want to do some one way and some the other. Okay, so let's look at the next one. Now, I didn't do this one because I want you to be able to do it yourself. Okay, so if we're looking at this, we know that this means the negative inside here means we're going to reflect across the y-axis, which is horizontal. And then we're going to move it down 1. So I'm going to move this point, the -3 is moved across to +3 and then moved down 1. This point, I'm going to reflect it and move it down 1. This point, I will reflect it and move it down 1. And this point, I will reflect it, and it has to go way off over here, and move it down 1. So when I connect my dots now, it goes here, and then here, and then here. Now, these two were pretty straightforward. And if you want me to fill this out, let me go ahead and take the time to do that. So here, my -3, -1 is going to become the opposite of -3, and then -1 minus 1. which becomes 3 minus negative 2. So there's the point 3, negative 2. So that one worked. Negative 1, 1 becomes the opposite of negative 1, and then 1 minus 1, which is 1, 0, which is that point right there. 4, negative 3 becomes the opposite of 4, and then negative 3 minus 1, which becomes negative 4, negative 4. So negative 4, negative 4, oops, it's right there. I didn't move it across one because the scaling's off. Okay, so that should be there. And finally, 6, negative 3 becomes the opposite of 6, and negative 3 minus 3. I'm sorry, that's a positive 3, and that's a negative 3 plus 1, which becomes negative 6, negative 2. I'm sorry, that's 3 minus 1, which is a positive 2. Okay, so you can do it either way you want. Now here on these, I'll just try and go from straight from here to the end. So the first thing I have to do, and I have to do these in order, is I have to shift left 2, do a vertical stretch by a factor of 2, and then move it down 1. Okay, so I'm going to take each, I'm so sorry. I'm going to take each of these points, and so I'm going to take this point here. I'm going to shift it to the left 2, double the y value, which brings it up here, and then move it down 1, so that goes to right here. This point, I'm going to move it to the left 2, double its value, and then move it down 1, so it comes to right here. This point, move it to the left 2, double it, so that makes it 6, and then move it down 1. Oops. Okay, no, that's correct. Then take this one, move it to the left 2, double it, and move it down 1, so it goes to right here. And then I connect my dots. And then if you want to do it algebraically, you know what you're doing is for your x and y, you're going to take the x and subtract 2. You're going to multiply the y by 2 and then subtract 1. Okay, now for this next one, you have to remember your order because you've got a horizontal reflection, you've got a vertical shrink, you've got a vertical reflection. So you want to do the horizontal translation first. Then you're going to do the vertical stretch and shrink. So you're going to do the vertical shrink by 1/2. Then you are going to reflect across the y-axis. reflect across the x-axis, and then finally shift up 4. Now, what that looks like in terms of, we're going to take the x, so our x and y are points. We're going to take the x and find its opposite. So the opposite of x. Then we're going to take negative 1/2 times y plus 4. This one, I think that doing it graphically is a little bit complicated, so you may want to do it. You can do it either way you want. Okay, so I'm going to take this point. Okay, a vertical shrink means I'm going to cut it in half. Then I'm going to reflect it across the y-axis, which means it goes from -3 to +3. Reflect it across the x-axis, so the positive 1/2 becomes negative 1/2, and then shift it up 1, 2, 3, 4. So this point becomes 3.5. Now, if you want to just test one and see if you're doing it correctly, if we take this point, -3, 1, and we take the opposite of -3, and then negative 1/2 times 1 plus 4, we get 3, 3.5. So again, if you want to test it one direction, whatever you want to do. Okay, this point, I'm going to shrink it, which means instead of -1, it becomes -1/2. Reflect it across the y-axis, reflect it across the x-axis, and then move it up 4. 1, 2, 3, 4. This point, I'm going to cut it in half so it comes down to here. It doesn't need to be reflected across the y-axis. It is reflected across the x-axis, and then it's shifted up 1, 2, 3, 4. And finally, this point, cut it in half, reflect it across the y-axis, then the x-axis, and then shift it up 4. 1, 2, 3, 4. And then you're going to connect your dots. So you'll have this and this and this. All right, let's talk about symmetry and our defined functions. So let's talk about symmetry again. All right, even or odd? Okay, so let's think about even. F of negative x equals f of x. For odd, f of negative x equals the opposite of f of x. Most functions are neither. Even graphically is y-axis symmetry. Odd is origin symmetry. So if you're doing it visually, then it's pretty straightforward. Okay, what I am going to do is get out some extra paper so I don't have to cram it up like I did before. All right. So if I have f of x equals negative x to the third plus x, the first thing I want to find f of negative x, which is the opposite of negative x to the third, plus negative x, which is equal to x to the third minus x. And I also want to find negative f of x, which is the opposite of negative x to the third plus x, which is x to the third minus x. Okay, so once I have f of x, f of negative x, and negative f of x, I can see if they're the same. So f of x does not equal f of negative x, so it is not even. F of negative x, when I compare it to negative f of x, they are equal, so that tells me it's odd. All right, so let's look at our next one. We have g of x, so let's look at g of negative x. That is 3 times negative x to the fourth minus 2 times negative x to the second plus 5, which gives us 3x to the fourth minus 2x to the second plus 5. Okay. If I look at negative g of x, then that's negative 3x to the fourth plus 2x to the second minus 5. Okay, so let's compare g of x and g of negative x. They are equal, which tells me it's even. So I'm done. Okay, let's do the next one. So let's look at h of x. Then h of negative x is equal to negative 4 times negative x to the third minus 3 times negative x to the second plus 3 times negative x minus 4. So that is negative 4 times the opposite of x to the third minus 3 times x to the second minus 3x minus 4, which is 4x to the third minus 3x squared minus 3x minus 4. All right, then negative h of x is going to be 4x to the third plus 3x to the second minus 3x plus 4. Okay, so if I compare h of x and h of negative x, so this and this, they are not the same. So it is not even. Then let's compare h of negative x to negative h of x. So we're going to compare these two and notice they also are not the same. So it is not odd. So it is neither. Now, they have a hint in here, and I'm hoping people will kind of make these connections on their own. If all your exponents are odd, then it's an odd function. If all your exponents are even, then it's an even function. If you have both, then it's neither. And remember that a constant this is the same thing as 5x to the 0, which is why it falls under the even. Okay, let's see what we've got here in our graph. This is clearly not y-axis symmetry. It does look like it's origin symmetry, so I'm going to call this one odd. This is not y-axis symmetry. It is not origin symmetry, so this one is neither. This one is symmetric across the y-axis, so this is even. And we'll go on to piecewise in our next one.